The commit policy applies to the live failover and move operations. Before talking about this policy, it is important to understand what happens in Zerto once a live failover or a move is committed. A commit means that the failed over or moved VMs will be promoted to the new live production servers on the recovery side. In the case of a live failover, this will also start reverse replication if you set it up. When you commit to a checkpoint, all other checkpoints in the journal are consolidated and removed to save disk space. Once the journal is consolidated, Zerto can no longer go back to any other point in time. To put it another way, you are essentially saying, I no longer need my journal history. This is the point in time that I want going forward. A commit policy is a rule for handling the outcome of live failover and move operations. Commit policies offer an additional layer of safety and control for the user. Through the commit policy setting, you can choose to manually commit, automatically commit, or automatically roll back failovers or moves. You'll set a commit policy as a global default, but you can change it on a per failover or per move basis. Let's talk about how the commit policy options apply to a real-world example, such as a ransomware attack. Let's say that you learn about an attack at 2:13 p.m. You select the first journal checkpoint of 2:12 and 53 seconds and initiate a failover. Then, after logging in, you see that the files are still encrypted and realize that you need to go back further than the last checkpoint. How will each of the commit policy options perform in this scenario? When none is selected, after validating the failover or moved VMs, you'll need to manually commit or roll back the operation. In our ransomware example, if we selected none, we'd be able to easily roll back and try a new checkpoint. There would be no risk of the wrong checkpoint being promoted to production. By design, the none policy does not consolidate the journal and base disk automatically. When selecting none, it's important to consider that if you leave a VM in a non-committed state for too long, it can run out of scratched disk space and cause the VM to lock up. Over time, it will cause your VMs to use more data store space than needed. Therefore, using a commit policy of none may be best in an organization where you have the internal resources available to manually be brought back online quickly if your production site is down. When auto-commit is selected, Zerto will automatically commit the failed over or moved VMs after a predetermined amount of time. By default, Zerto waits for 60 minutes before auto-commit happens. In other words, without manual intervention, Zerto will automatically commit to whatever checkpoint you selected without asking you to confirm. In our ransomware example, if you kept the auto-commit default of 60 minutes, you'd have an hour to roll back the operation and try a different checkpoint. If you missed the window, you'd be stuck with the bad copy of data after the 60 minutes is up. If you are failing over to a DR site after a disaster, this option is the easiest. Once you click Failover, everything else is automated to bring VMs online at the DR site. However, use caution if you're trying to recover from data corruption when you aren't sure of exactly what checkpoint to use. You'll want to ensure you have enough time to validate your data before Zerto auto-commits to your selected checkpoint. The auto rollback is essentially the opposite of auto-commit. When auto rollback is selected, Zerto will automatically roll back the failed over or moved VMs after a predetermined amount of time. By default, Zerto waits 10 minutes before initiating an auto rollback. Without manual intervention, Zerto will automatically roll back everything that was failed over or moved. In our ransomware example, if you kept the auto rollback default of 10 minutes, you'd have that amount of time to manually commit the operation. If you missed the window, you'd revert back to the production system, which, in our example, is corrupted by ransomware. However, there isn't any risk of committing to the wrong checkpoint by using auto rollback. As you consider your commit policy, it's important to think about the goal and structure of your operation, including your organization's internal people and processes. Consider how much time you will need to decide to commit or roll back VMs, and how you will validate that the VMs at the recovery site work as expected and have the correct data. You may also want to consider what planned or unplanned downtime your organization may encounter. For example, a corruption such as our ransomware illustration may require a different policy than a natural disaster.